Now we're going to use matrices to solve systems of equations. And to do that, we need to talk about row transformations first. So first of all, a matrix is just an array of numbers, and an augmented matrix is, we've got the last column delineated with that bar, and it's going to have exactly one more column than row. Now, why? We can use an augmented matrix to solve a system of equations. If I have a system of equations, like a standard equation, maybe something like 3x plus 5y plus 2z equals 17, I would put the coefficients of the x in the first column, the coefficients of the y in the second, the coefficients of the z in the third, and then whatever's on the equal to sign in the fourth column. So I would read this backwards, back to an equation saying a1x plus b1y plus c1z equals d1. And then my second row would be a second equation, the third row a third equation, and so on. So any two rows may be interchanged. That's like writing the equations in different orders. It wouldn't change the solution to the system. The elements of any row may be multiplied by a non-zero real number. That's equivalent to multiplying both sides of an equation by the same non-zero real number. The equation would stay balanced. Any row may be changed by adding to its elements a multiple of the corresponding elements of another row. That's what we do in the elimination in solving a system of equations. We multiply one equation by whatever we need to knock out a variable in another equation, and then that resultant is replaced in the system. It's still part of the solution to the system. Excuse me. So we want to use row transformations to transform this matrix into this matrix. So notice that in our first matrix here, the third row stays exactly the same, but the second row became the first and the first became the second. So if I call this row 1, this row 2, and this row 3, then all we're doing is we're switching row 2 and row 1. In your homework or quizzes, when you're doing this, you can just use this notation to indicate you're switching row 1 and row 2. All right, now let's look at what's going on here. Row 3 stayed the same, row 2 stayed the same, but the 1 became a -2, 3 became a -6, 5 became a -10, 2 became a -4. I'm multiplying the top row, row 1, by a -2 and putting it back where row 1 is. Let's look at what happened here. Row 1 stayed the same, row 2 stayed the same, but here my 1 became a 0, my -1 became a -4, -2 became a -7. It's not just changing by a constant, but if I notice here, if I subtract row 1 from row 3, the result will be what's here. 1 minus 1 is 0, -1 minus 3 is -4, -2 minus 5 is a -7, 4 minus 2 is a 2. So I'm taking row 3 and subtracting row 1 and putting it back where row 3 is. Now I can do these operations on my calculator after defining my matrix A. I can use the row swap to swap two rows, or here I can multiply a single row by a constant, or here I can multiply a row, add or subtract different values of rows. So you can use these operations, but I'm going to show you more helpful things to do on the calculator. Now, echelon form is where we have ones down the main diagonal and zeros beneath. Now, the benefit of this, remember, this is like my x column, y column, z column, and equal to column. If I read this last row, it says 0 x's plus 0 y's plus 1 z equals 4. I have a solution for z. The row above says 0 x's plus 1 y plus 2 z equals 9. So if I plug this value of z in there, I can figure out what y is. Plug the y and the z into the top equation, and we can get the x. So echelon form makes it easy to solve my system by back substitution. Here, to solve the system of equations, we're first going to put it in a matrix. My first column, or my coefficients of the x, so 1 and then 2. coefficients of y, 2 and then 1, and then the 5 and the negative 2. So to get a 0 here, I'm going to take negative 2 times the first row, add it to the second, and put it back where the second row is. So the first row will stay the same, but then negative 2 added to 2 will make a 0. Negative 4 added to 1 is a negative 3. Negative 10 added to negative 2 is a negative 12. Now to get to echelon form, I need a 1 here. So I'm going to divide row 2 by negative 3 and put it back where row 2 is. So row 1 stays the same. 0 divided by 3 is 0. Negative 3 divided by negative 3 is a 1. Negative 12 divided by negative 3 is a positive 4. So notice this tells me from this last equation, 0x's plus 1y equals 4. And then from the top equation, 1x plus 2y equals 5. Well, if I know that y is 4, x plus 8 equals 5, so my x is a negative 3. Okay, this tells me the solution to the system. X is a negative 3, y is a 4. I can plug it back into the system to solve to make sure that it works. Let's see how to do this on the calculator. So I'm going to go into second and matrix, and I am going to edit matrix A. I need 2 rows, 3 columns. I've already filled in the values for our original matrix here, 1, 2, 5, 2, 1, negative 2. Once that's all filled in, go back to the home screen, second matrix, and I'm going to go over to the math key, one arrow over one time, and I'm looking for where it says REF. That's the option A on my calculator. Then second matrix, pick up matrix A. And notice it gives me 0, 1, 4, the exact same row I have down here. So my y is 4. Now it gives me a slightly different form up here. We didn't need to do that because we already had it in echelon form. Echelon form is not unique. But this is an equivalent. If we solved this system, we'd see we got the same thing. Y is 4 and x is negative 3. All right, let's solve this system. So first thing that we do is we put it into a matrix. So we're going to go 3, negative 2, 1, 2. That's my first equation. My second is 1, 2, negative 2, 1. And then 1, negative 4, 2, and negative 1. Now to get in a row echelon form, I need a 1 here. But rather than start working with fractions right away by dividing by 3, I'm just going to flip the 2 rows. So I'm going to flip row 1 and row 2. So I'll have 1, 2, negative 2, 1, 3, negative 2, 1, 2, 1, negative 4, 2. All right, now if I do negative 3 times row 1 and add it to row 2, I'll get a 0 here. So row 1 stays the same, 1, 2, negative 2, 1. And then negative 3 added to 3 is a 0. Negative 6 added to negative 2 is a negative 8. Positive 6 added to 1 is a 7. Negative 3 added to 2 is a negative 1. The third row stays the same. 1, negative 4, 2, negative 1. Now I need a 0 here. So I'm going to do negative row 1 added to row 3, and put it back where row 3 is. So 1, 2, negative 2, 1 stays the same. 0, negative 8, 7, negative 1 stays the same. But on this one, we're going to go 1 minus 1 is a 0. 2, negative 2 added to negative 4 is a negative 6. Positive 2 added to 2 is a 4. And then negative 1 added to negative 1 is a negative 2. Now, I want to get a 1 here. I think this row is going to be a little easier to work with when I divide through to get a 1 in place. So I'm going to flop row 2 and row 3 first. So I will have 1, 2, negative 2, 1. Now 0, negative 6, 4, negative 2. 0, negative 8, 7, negative Now I'm going to divide row 2 by -6 and put it back where row 2 is. So I'd have 1, 2, -2, 1, and then 0, +1, because I'm dividing by -6. Now if I divide this by -6, it makes -2/3. And if I divide this by -6, it makes a +1/3. And then 0, -8, 7. All right, so now to get 0 here, I'm going to do 8 times row 2 and add it to row 3. Let's see, I'm running out of room here a little bit. Let's go over here. Okay, so the first row stays the same, 1, 2, -2, 1. Now the second one stays the same, 0, 1, -2/3, 1/3. But then I have 0 added to 0, that's a 0. 8 added to -8, that's a 0. All right, now I'm multiplying this by 8, so it's -16/3 added to 21/3 is 5/3. Multiplying by 8, 8/3 added to -3/3 is a 5/3. So now I'm going to divide row 3 by 5/3, or equivalently multiply by 3/5. And I'm going to put that, I'm really running out of room right here. So 1, 2, -2, 1, 0, 1, -2/3, 1/3, and then 0, 0, I'm dividing by 3/5, so that would be a 1 and a 1. All right, so that tells me that z is 0x plus 0y plus 1z equals 1. Once I know z equals 1, I plug in here. This is saying 0x plus 1y minus 2/3 z equals 1/3. Well, if z is a 1, then this is just a -2/3. Added over here, we get 3/3. Y is also 1. So once I have the value for z and y, I plug it into the top equation, which happens to be this one right here. So I'd have x plus 2 times 1 minus 2 times 1, that's 0, equals 1, x is 1. So my solution to this equation is x equals 1, y equals 1, z equals 1. I can write that as the ordered triple 1, 1, 1. Now, check to make sure that it works by plugging into each equation and making sure you end up with a true statement.